All right, hello and welcome. We're going to do a little review here. You got a quiz next class. I know it's a unified day, but I was thinking, well, we could do a little more. It's just a quiz. You got 40 minutes. We'll jump right into it. You'll be fine. We're kind of a little bit behind still, and I'd like to catch up, and this would be a great opportunity to. So you got a quiz on Wednesday. I'll be back tomorrow on Tuesday. So if you need to come in before school, after school, I will be there to help on Tuesday. Or send me an email. Happy to communicate with you through email on Monday as well. So, quiz next class, and then we got to wrap up chapter three, and we got to get going on chapter four, guys. Like, come on, man. You know? Let's go through this together. Then you got some other problems to work with in your book. Please be nice to your sub. Okay, so we've done some of this stuff, but this one's a little bit different. So we got two parallel lines here. So we want to use our Delios. 11 is 62. We want to use our angle pair relationships is what I was trying to say. 14 is 38. We got to be a little careful here. Like if you were going to say alternate interior angles like 7 and 5, well, that wouldn't be right. 7 is alternate interior with 5 and 6. 7 and 4 are same side interior. So you just got to be a little bit careful. Like, okay, this is my transversal, but this is just an extra line for now. Or if I'm going from this direction, this is my transversal, and this is an extra line. So be a little bit careful. But an easy one to start with is 11 and 4 are corresponding, right? So 4 should also be 62 here. And 6 should be 38. Okay, so then to find 5, we know this is a straight line. So we could do 180 minus 62 minus 38. Let's see, 62 plus 38 is what? 100? So 5 is 80. Now, again, remember, these could be a little bit not proportional, but that kind of makes sense. So we get that. And then this one's really easy because we got all these verticals. So this is also 80. This is also 62. This is also 38. So this isn't too bad, but you just got to be a little careful with that first step. And there's a bunch of ways you could have done that first step, right? We could have said, wait, whoa. No, yeah, that works. Yeah, that works. Yeah, I think that's right. So then 7 and 11 add up to 180. So seven's going to be uh 118. Yeah, which works because look, 7 and 1 and 2 together are corresponding, and those add up to 118. Okay, so everything's coming together here, and you can just go through now and do vertical angles, linear pairs, and find the rest of them. It's just getting that first couple in and being careful with the two transversals that you got to be a little careful about. Okay, let's move on here. Okay, so again, we got parallel lines. We know one y and 114 are corresponding angles. So we're going to go ahead and say y is equal to 114. And then we know these are a linear pair. So we can do x plus 12 plus 114 equals 180. Nice, nice, nice. Boy, what is all that? Okay. Do it a step at a time. Do it a step at a time. So we get x plus 126 equals 180. So what is that? 54. Okay, so we get x equals 54. Y was 114. You get your two variables. Nothing too crazy about that one. Next one, a little bit trickier, maybe. Again, this one you got to be careful, right? So the parallel lines are this one. These are not parallel. So we can't, you can see right here, 120 and 108 are not corresponding angles. I mean, they are in the sense They're in the same place, but they're not equal because these lines aren't parallel. You can see that. So we can't say 5y is equal to 2x. It doesn't work that way. What we can do is look at these are parallel. Here's our transversal coming through if you extend the lines. 5y and 120 are same side interior. Okay, same side interior or consecutive interior are supplementary. So we can do this and say that they equal 180. So then 5y is equal to 60. So y is equal to 12. Okay? Now, look at this. So now this one has a different transversal, right? Oh, such a good line. What a great line. Let's do it again. It's actually, would they have one that's dotted? So if we do, oh boy, Alberto. That's what I'm talking about. Okay, so if that's the transversal, what's the angle pair relationship between 2x and 108? Alternate interior angles. Now, those are congruent. So we could say 2x equals 108. So x is 54. Okay? You have some problems like that on your quiz. Just going through and going with that. Out of water. What's going on here, man? All right. So that is, you got some problems where you're just finding missing angles using angle pair relationships, parallel lines, linear pairs, vertical angles. You're just practicing all of that stuff. All right. Part 2 of the quiz is linear equations, which we spent a little bit of time on. So I just gave you a little practice the old slope ski here. So remember, this was 3.3. Remember your slope equation. You gotta have this memorized, kids. You should already from last year. Whoa, that went a little far. Just y2 minus y1 minus x2 minus x1. y2 minus y1 over x2 minus x1. Again, always helpful. We're just gonna do one of these. Label a point. And then we just go ahead, we plug that in. So we get -5 minus 0. Love it. That's easy. Over 4 minus 2. So we get -5 over 2. Do not turn that into a mixed number for cheese, you know? Geez Louise. So -5 over 2. Okay? That's your slope. Nothing too crazy there. Nothing too crazy. Find the slope. Next problem. So we want to find the equations in both slope, intercept, and point slope. I don't know, maybe you can't see that. It says point slope there. And it's going to pass through 2 points, okay? L and M. So first thing we want to do is we want to find the slope because we got 2 points and we don't know what the slope is. Let's call this one x1, y1. Call this one x2, y2. And y's on top. We go -12. It's minus a negative, so it becomes plus 3 over 8 minus a negative. Oops, sorry, mix those up. Got to do x2 first, Mr. T. So we got -4 minus 8. Have we seen this problem before? Looks familiar to me. So we get -9 over -12, and that simplifies to 3/4. Negatives cancel. So now we could do it a couple different ways. It depends on what you're more comfortable with. So you could start in slope intercept and then just do point slope. Again, I think it's really nice to start in point slope. Okay, this is point slope. Y minus y1 over, or sorry, over, Jesus. Sorry, kids. Y minus y1 equals m times x minus x1. Okay, and you plug in your slope, right, which would be 3/4, and then we pick one of these points to plug in. I'm going to go with the double negative just because it'll look kind of cool. So I'm going to go y plus 12. This turns positive because you get minus a negative, equals 3/4 x plus 4. Okay, and if I just asked you for an equation in point slope, well, guess what? You got it. Okay, look how nice that is. Your equation is done. No finding y-intercept garbage. Um, and then if you want to turn it into point slope, just distribute this. Okay, just distribute this, guys. So we get y plus 12 equals 3/4 x. Now 3/4 times 4, the 4's cancel, so you just get 3. And then we can subtract this 12. And we get y equals 3/4 x minus 9. And there's your equation in slope-intercept. So it can be really, really nice and easy and useful. Useful. Okay? That's the plan. So one more. We got two more problems, okay? One more linear one. So we want to find a line that's perpendicular to this line, but it passes through this point. I don't know if you can see that point. It's a -2, -8. I'll rewrite it so you can see it. Okay, now perpendicular slopes, remember, flip it, change the sign. So let's do this one in slope intercept because you guys are more comfortable with that anyways. So we're going to go y equals, we're going to go just 3/2 x. We change the sign so it's positive, and we flipped it. Okay, so flip it, change the sign like we just did. We don't know what the y-intercept is, okay? We just don't. But we can figure it out. We're going to plug in our point. -8 for y, -2 for x, and solve for b, which is our y-intercept. So again, the 2's cancel, but don't forget this negative. So we get a -3 there. And then we're going to add that 3 to get b by itself. And we get b equals -5. Okay, and then what do we do with this? We're not done yet. Don't you put that pencil down. We're going to plug this back in. Whoops, went right into that b. And we get y equals 3/2 x minus 5. Okay, and there you go. That's your equation that passes through this line that is perpendicular to this line. Sorry, passes through this point that's perpendicular to this line. Uno más problem. Reminder before we do this that this is pretty tough. It's just pretty tough to find good questions for these proofs. So just keep that in mind. Okay, so we know 2 and 3 are supplementary. We want to prove that A, B, and C, D are parallel. You can see this is not hard. It's hard to find good proof, so I apologize. There's one proof in your little, you can do a little bookwork here. And there's one proof in there, that's okay. It's hard to find good proofs. Look through your notes. That's why I said really write these proofs down. So we're going to say angle 2 and angle 3 add up to 180. That's definition of supplementary angles. Okay, and then look at 2 and 3. 2 and 3 are what kind of angles? Okay, they're same side interior. We just showed that they're 180. So these lines have to be parallel. Really kind of a lame proof, guys. I know. Make sure when you study for this quiz, look through your notes at those examples we did in class. Do the one, what was the reason? What'd you say? Same side interior angle converse? Yeah, you got to have converse there, okay? That's the important part. Converse is the important part. Anytime you have a statement that says two lines are parallel, you should have converse there. Hope you're all doing great. Look through your notes on the proofs. Try to find some other proofs you can do. There's one in your little bookwork you're going to do in class. Treat the sub nice. Email me if you have questions. Come in Tuesday if you have questions. Quiz on Wednesday. We will see you then. Have a great day.